All right, everybody say hi, Libby and Claire and Jake.
Hi, Libby. Hi, Claire. Hi, Jake.
Okay, 2-5 is proving segment relationships. There is things that we're going to write down on our blue sheet, which is this guy right here. And then there's some things that we're not going to write down on our blue sheet. Like this first one is the ruler postulate, okay? And here's what the ruler postulate says. It says, the points on a line or line segment can be put into one-to-one correspondence with real numbers. And what that means is, this line segment, I can measure it with a ruler.
I think I can.
I can measure it with a ruler, which seems really stupid. If you have a line segment, you can measure it with a ruler. That's what the ruler postulate says.
Okay.
Silly. We're not going to write that on the sheet, okay? It makes sense. We can measure it with a ruler. That's all, okay? But this next one is called the segment addition postulate. And segment addition, you are adding segments.
There's a what?
There's an orange fingerprint on my paper.
Does Donald Trump after his panties?
All right, segment addition postulate. Here we go. You guys are all on fire today. All right. Segment addition postulate says if we're given a segment like AC and B is visibly, obviously not in the middle, we can take AB and add it to BC and it will be the whole length, right? Like if AB is 12 and BC is 5, then this whole thing is 17, right? Okay? All right, so we're going to write that thing down because we will use it to prove things. So go to your thing and go to segment addition postulate. It's POST 2.9. And we're going to write him down.
Segment addition
POST 2.9.
POSTULATE. 2.9.
Post 2.9. Segment addition postulates. And what I'm going to do is I'm going to do the drawing over here of him, but make it obvious that B is not in the middle. Okay, so I don't care if you put him closer to A or closer to C. I'm going to put him closer to A. Make him obviously not in the middle to prevent yourself from thinking that they're equal to each other. Okay, and what segment addition postulate says is that if I take AB and I add it to BC, then I will get AC. And that is all. Okay, now before we go back to the next page, keep on this same page because we're going to add something on here which is not on your note sheet. But we're going to add something on there because this is something that they will have you do in a proof a lot. Okay, and it's kind of silly, but we'll go over it. Okay, are we good so far? All right, the next thing, I want you to write this on here because we will use this quite frequently. It is something called the definition of congruence. The definition of congruence. Okay? And this is kind of silly. The definition of congruence does this. So basically, if you have, like, let's say AB is equal to BC. Let's say we have something like that. Let's say AB is equal to BC. Something like that, right? This is talking about them as a measurement or as a length, right? MEASURE. That's a measure. The measure of AB is equal to the measure of BC, okay? The definition of congruence allows me to write segment AB, which has a segment bar, is congruent to segment BC, okay? It allows me to go from their measurements being equal to the segments are congruent to each other. That's definition of congruent. If their measurements are the same, then they are congruent to each other, which kind of seems silly, but that's kind of the way that it works, okay? So that's definition of congruence. They're going to have us do that in this proof down here. So here we go. First proof of the day, okay? Prove that if, this is our given information, CE is congruent to FE, and ED is congruent to EG. Those are the things that we have that are given. Do you see where it says if? That's this part right here that I'm writing down. Then what we're trying to prove is that CD is congruent to FG. And before we start, we're going to mark this diagram up over here and we're going to see what they're actually saying. Okay. All right. So they say CE is congruent to FE, and CE is this little piece right here, and FE is that little piece right there. So they're saying that those two pieces are the same, yeah? Okay? And then they also say that EG is the same as ED, but I'm going to use 2 tick marks so that you don't think that it's the same as the other little pieces, right? Okay? So those are the same, right? And so they have the little pieces are equal to each other and the big pieces are equal to each other, and what we're trying to prove is that this whole segment is equal to this whole segment, right? Wouldn't that make sense, right? If the small pieces are equal, the big pieces are equal, the whole thing is equal, right?
Yeah.
We're just trying to prove that by writing out all the work for it, okay? So what we're going to do is we're going to start with the given. So CE is congruent to FE and ED is congruent to EG. Okay, those guys, and that is what we are given. This is kind of a longer proof, longer than what we were doing yesterday. A little bit longer, okay? A little bit longer. All right, now I'm going to do that definition of congruence thing where we take them out of the congruent sign and we make them equals. So I'm just going to say CE is equal to FE, and I'm going to do a comma instead. ED is equal to EG. Okay, so I'm just taking away the congruence symbol and I'm just going to say that they're equal. And that is called the definition of congruence. Okay, if you want to go definition of and write the symbol for congruence, you can do that as well, right? So if you want to abbreviate and be lazy, you by all means can do that. Okay, all right, so now we have this going on here. All right, we're going to use the segment addition postulate somewhere, right? We know that we're going to do that. So let's do our segment addition postulate for like this piece that goes this way. What can we do? What segments can we add together to say are equal to the whole segment? What would we do there?
CE and ED.
Okay, so we would say like CE plus ED will be equal to CD, right? Agreed?
Mm-hmm.
Okay, now let's do the same thing. We'll write that on the same line, but we'll do it for this one. So what will that look like?
FE and EG.
FE plus EG equals FG, right? And that all is the segment addition postulate. And I'm abbreviating everything. Segment addition postulate. There it is. Okay. Okay. All right. Okay. This is where the tough part comes in. Okay. Are you ready?
Mm-hmm.
We're clear so far. We know what's going on.
Mhm.
Okay. We are trying to get to CD and FG being the same, right? CD and FG are right here. Okay. So I have that CD equals this stuff and FG equals this stuff. Okay. And so if I'm trying to prove that these two things are the same, I'm trying to make these two look the same. She says, wait,
They
what?
are the same.
They are the same, right?
Mm-hmm.
Okay. So here's what I'm going to do. I'm going to cheat. Well, kind of, not really. I'm going to say, okay, we know that CE from this step right here. Take a look at this step. Okay. We know that CE and FE are the same, right? So what I'm going to do is I'm going to take FE and I'm going to plop that in for CE and I'm going to call this thing FE. Don't write this down yet. Okay. We're going to call that thing FE, right? Okay. Because that's what he is, right? And if ED and EG are the same, I'm going to take EG and I'm going to plug him in here, right?
Mm-hmm.
Right? So then both of these statements are going to say FE and EG, right?
Mm-hmm.
So then those two things are equal, right?
Yeah.
Right? If they both say the same thing. Okay, so let's write out what we just did here. Okay, what I'm going to do is I'm going to change this top segment right here. I'm going to change it so that instead of saying CE, he actually says FE, right? Because that we've taken FE and we've plugged it in there, right? Okay, and instead of saying ED, what are we going to say again? EG, right? We're going to take that EG and we're going to plug that in there. Okay, so EG, and that's equal to CD, right? Do we see how we get that? Now, what did we do to get that? Like, why is that legal? Why can we do that? What did we just do? What was that process? We took him and plopped him in there. What's that? What's another word for that? Taking him and plopping him in there. I don't think we've written him down on your blue sheet yet. What was that process called, though? We took him and plugged him in. What's that called?
Substitution.
Substitution. Yeah.
I'm so good.
Substitution. We just plugged him in. That's a substitution
You're a
property.
history teacher. What do you know about math?
Okay, that's a substitution
They're gonna
property.
be so confused when they're watching this stream.
I know.
What is going
Haley's dressed up as Mr. Brown, so she doesn't know math because she only knows history.
She's
So
an art
there's the
teacher.
deal.
She can't talk either.
Yeah, yeah.
Okay. At least I'm good at something.
Oh, shoot.
You just
Words have been thrown. Words have been thrown.
She really is.
I'm gonna tell Mrs. Brown that you said she's not good at math.
No, she's not good at math.
Okay, so now we have these two steps. I'm going to look at those two steps right now, okay? And we want CD and FG to be the same, right? But if CD, let's go back. if CD is equal to this junk, can't I just take CD and plop them in for that stuff right there, right?
Yeah.
So I have CD replacing all that good stuff, and CD equals FG, right? Can I do that?
Yeah.
Okay, what was that again?
Substitution.
That was substitution again. That's substitution again. We just did like some back-to-back substitution. So that's the substitution property. Okay? Now we're almost
I
there.
literally do not have that much.
Now we
left.
sign it.
We're almost there. No, not yet. We want CD is
have
congruent
to
to
do the
FG.
congruent.
So we've got to do CD is congruent to FG, and that is by definition of congruence. We are able to say that they're congruent, and then we're done. Okay?
Oh my gosh! Every time I try and write the congruent sign, I always try and make a pi sign instead.
See?
Yeah,
I do that
there you go.
too.
Yeah, with a little squiggly on top.
Mhm.
Yeah, I see that. Okay, I get it.
The pi sign? Yeah, you know.
Do you know what pi looks
Because
like?
instead of 2 horizontal lines, she does 2 vertical lines and with a squiggly, right? I don't know. Anyway.
I don't know.
Because you do the squiggly line first, and she wants to put the lines like that instead of like that.
Oh, I make the equal sign first and then the squiggly, and it
That's
helps.
what I do.
Yeah.
No,
Yeah.
I do the
Jaden's-
squiggly before the equal
Jaden's
sign is
bashing
what
our
I
whole
do.
class and calling so loud. I just like you want to know that.
She what?
She's like, you guys are so loud. Why? I'm like, it's because it's 4 girls in here. She goes, even Comature is being loud. I'm like, that's
I
because you have
mean-
to talk over 4 girls.
Where is she?
Walls are
Oh, okay. The walls are thin. Yes, correct.
Jaden's
right.
loud.
Right.
Yeah,
Okay.
Jaden, you can't say anything.
Now we have, do you remember before we wrote down the reflexive property, the symmetric property, the transitive property? Okay. Now, these are the reflexive transitive property of congruence. So go back to your sheet here, and on your blue sheet, we wrote down the symmetric property and the transitive property, but instead of doing the property of equality, this is the property of congruence. So POC instead of POE. So it works for things being congruent, because congruent is kind of the same as equals, right? But it's property of congruence instead of property of equals. So transitive and symmetric. Oh, wait. Yeah, transitive and symmetric. Property of congruence and property of
I
congruence.
did that wrong.
Okay. So we don't have to rewrite them down twice on your blue sheet. We can just write property of congruence. Okay. All right. Good. One more thing that we're going. No. We're not going to add it right now. Let's go to the proof. Okay. All right. Let's go straight to the proof, and they give us words here, which is confusing a little bit. Okay. But look at the diagram. So as I read these words, look at the diagram to see what this looks like. All right. So it says it does look like a V. The route for a charity fitness run is shown. Checkpoints X and Z. Okay. Checkpoints X and Z. These are the two that we're talking about. They are the midpoints. Okay. So that's a piece of given information, but let's write it like in easier terms. Like X is the midpoint of SY. That's a given piece of information. Then they also say Z is a midpoint. So Z is midpoint of YF. Okay, so those two are midpoints, all right? And then they give us one other piece of information. It says checkpoint Y is the same distance from checkpoints X and Z. Okay, so here's the deal. Checkpoint Y is the same distance from X as it is to Z. So what can we say there? So I'm going to go XY. I don't know why I'm doing XY. XY is congruent to YZ. We'll just go like that. XY is congruent. I don't know. It's just going to be nicer in our thing. Yeah. XY is congruent to YZ.
In the alphabet.
Okay, this is going to be a little bit longer of proof. Now, what we're trying to prove, what we're trying to prove is that checkpoint Z to the finish line is the same as the starting line to checkpoint X. So we're trying to do this and say that this is the same as this, right? That's what they're trying to say. So they're saying prove that. So we're trying to prove that ZX is congruent to, SX is congruent to ZF. Those are the things that we're trying to prove. Right. Yeah. So we just got to talk through that, and we got to write all that stuff down. Okay? All right. So, here we go. Let's do this. Let's start with the given. Now, I'm going to do something weird real quick, and we have lots of given information, but I'm not going to write it all down at once. I'm just going to write X midpoint of SY and Z midpoint YF. That's all I'm going to write down. I'm not going to write down that last piece of given information yet. Okay? That's all given. All right. Now, from that information, If I know that x is the midpoint of sy, what does that tell me? If this guy is the midpoint.
SX and XY.
Sx is equal to xy. You betcha. Sx is equal to xy. Like this is the same as that, okay? And if z is the midpoint, I also know yz equals zf. Do we understand why that is? Yeah? Now, why am I allowed to say that?
The midpoint theorem.
The midpoint theorem. Midpoint theorem. Okay, it's saying that that's the midpoint, all right? So I haven't even written down all my given information, but I used that given information to find something else. Now let's incorporate the second piece of given information, which is xy is congruent to yz, okay? And that's given to me, okay? But before we start working with that, let's change him over. Do you know what I mean by change him over? Xy is equal to yz now instead, which is the definition of congruence. Okay, so we've got to make him congruent now instead. Okay. All right, and all right, let's look back at this information right here. Let's check that out. That second step right there. Okay, and what we're trying to do is we're trying to show that Sx is the same thing as Zf, right? Sx is the same thing as Zf, right?
Yeah.
Okay,
Because
well.
of the Skippy thing.
Right. Well, it kind of looks like cross multiply. But do you remember when we had, like, before we had, like, A equals B and B equals C, then A equals C, we can cross them?
That's what I was thinking.
If the B's are, that's a transitive property, right? If the B's are the same. Now, our B's aren't exactly the same, because one of our B's is XY, but another of our B's is YZ, right? But we're going to change it by using this, right?
Then change it.
Can we change it? Okay, so I'm going to leave Sx equals xy. I'm not going to change that. I'm just going to write him straight down there, right? I'm just going to leave him alone. But then this guy, when I bring him down here, instead of putting yz is the same thing as xy. So I'm going to put xy in his spot, right? This was the one that I plugged in, right? Mm-hmm. And that's zf, yeah? So I'm changing out this yz and I'm putting xy in there, right? And that is substitution. Okay, substitution. Okay, now we do have A, B, and B, C, right? We have our x's, xy, and xy. So we are allowed to say that Sx is equal to Zf, and that is because of the what again?
Transitive property.
Transitive property. Okay, and last thing, we're almost done. We're trying to say Sx is the same thing as Zf, but now we do our definition of congruence. So Sx is congruent to Zf. Yeah, definition of congruence. Does that make sense? Mm-hmm. Yeah, that one's not too bad.
I did a Python.
Like, I understand how we're doing it together, but I definitely couldn't.
Yeah. Sometimes like my strategy sometimes is start with the given information and then just draw out any pieces of information that you can. Like if I know that we're talking about a midpoint, okay, I'm gonna write out what that means for midpoint, right? Okay, that type of thing, okay? So there's that. Okay, good. Now, the very nice thing, let me see. I don't know if I've put your homework assignment on here. Sorry, you people are watching this video. You're gonna be really dizzy. Sorry. I apologize. Blah, 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 blah. Nope, I don't have it on here. I don't think. No, I do. No, I don't. On your homework assignment.
Ew.
So you people watching this video on your homework assignment, here's the deal. I will show it to you. Take a look at this. On your homework assignment, they have the blanks that you just fill the blanks in, right? So they kind of have it ready to go for you. Okay. Oh, shoot. Did you guys put your blue sheets away? No. I want to add one more thing to a blue sheet. Can we add to a blue sheet? Okay, I have one more thing because it doesn't really make a whole lot of sense, so I'm going to explain it to you. Because when they give you the blanks on your homework assignment, they have one thing that doesn't really make a whole lot of sense, and it is the substitution property. So I'm going to write that down. Substitution property. Okay? Now, the substitution property, we know what substitution is, right? We've used it already. But it also means, also used for simplify. Okay, it's also used for simplify. Let me show you what I mean by that. Okay, I'm going to write a mini proof over here for some stuff, okay? So let's say we have our statements, we have our reasons, and I'm going to show you just like a little mini proof. And let's say we are given that x minus 4 equals 3, and that's my given, okay? Here is what they will write, okay? To get that 4 to the other side, we do x, we would add the 4, right? So that's the addition property, but here's how they will write it. They will go x minus 4 plus 4 equals 3 plus 4. That's how they will write it, and that is the addition property step, okay? But in the next line, then they will finally write it as x equals 7. And you're like, wait, crap, I've already used the addition property up above. What's this one? They will write this as the substitution property, right? So it kind of looks weird. It's not really substitution. You're kind of just like simplifying and like crossing those 4s out, right? But they call it substitution for some reason. So I'm going to put that in there. There it is. Okay? Everybody say bye.
Bye.